Let's evaluate two analogies presented to explain the principles of current and voltage. The first is the plumbing analogy. This analogy compares supply lines to hot wires carrying current and voltage, which is likened to water under pressure. Neutral wires are compared to drain pipes, carrying waste, representing current, but at zero pressure or 0 volts. The second is the dump truck analogy. Here, dump trucks deliver their load to a site, which is equated to current times voltage, or power. The load represents voltage and the truck represents current. After delivery, current, or the trucks remain, but the load, or voltage, is gone. The dump truck analogy is considered a better representation than the plumbing analogy. The plumbing analogy isn't ideal because this inaccurately portrays the relationship between current and voltage. It suggests that supply lines carry both current and voltage while neutral wires carry only current. However, in an electrical circuit, current flows through both the supply and return path, and voltage exists as the potential difference between the supply and return path. The dump truck analogy is superior because it more accurately reflects the relationship between current and voltage. The dump trucks symbolize current and their cargo represents voltage. The delivery of the load signifies the transfer of electrical energy, voltage, to the load. The continuing presence of the trucks after delivery illustrates that current continues to flow even after the voltage has been utilized. This parallels an electrical circuit where current flows while voltage drives the energy transfer. When the circuit is open, the current stops, but the potential difference, or voltage, may still be present. To further clarify, consider the following. 1. Current is the flow of electrical charge, measured in amps. 2. Voltage is the electrical potential difference, measured in volts, that drives the current. 3. Resistance, measured in ohms, opposes the flow of current. The relationship between these three is defined by Ohm's law, which states that voltage equals current times resistance. Analogies, while useful for conceptual understanding, have limitations and should not be taken as a perfect representation of the underlying physics.